Scientists discover Earth's official expiration date. For 4.5 billion years, our sun has been the lifeblood of our planet. It's warmed our world, fueled our civilizations, and watched life blossom in countless forms. It feels permanent, doesn't it? A constant, comforting presence in our sky. But what if I told you that this gift of life comes with a non-negotiable expiration date? I'm not talking about a stray asteroid or a cataclysmic war. This is an official end, coming from the very star that gave us life. Using advanced supercomputer simulations, scientists have uncovered the inevitable countdown to the end of the world. They've peered billions of years into the future and discovered that our planet's life support system has a precise point of failure. The end has a start date, and the process is already, quietly, underway. Section 1. The Sun's Internal Clock. To understand our end, we have to understand our star. The Sun isn't some timeless ball of fire. It's a middle-aged star with a life cycle, and it's getting older. Deep in its core, it's been fusing hydrogen into helium for billions of years. This nuclear reaction is what produces the light and heat that sustains us, but it can't last forever. As the sun ages, it gets hotter and brighter. For every billion years that pass, the sun's luminosity increases by about 10%. That might not sound like much, but over geological time, it's a death sentence for a planet like Earth. This steady, relentless increase in solar energy is the engine of our destruction. It's not a question of if this heat will overwhelm our world, but when. And thanks to sophisticated models from institutions like Japan's Toho University and NASA, we now have a timeline. The first victims of this slow burn apocalypse won't be us, but the very foundation of our ecosystem, plants. Section 2. The Great Suffocation begins. The countdown to extinction doesn't start with fire, but with starvation, specifically carbon dioxide starvation. Here's how it unfolds. The sun's increasing heat will accelerate a process on Earth called silicate weathering. Basically, the warmer temperatures speed up chemical reactions that pull CO2 out of the atmosphere and lock it away in rocks. For a while, this isn't a huge problem, but there is a tipping point. According to scientific models, complex life could be in trouble in about 800 million years. At this point, CO2 levels are expected to plummet so low that C3 plants, which make up about 99% of plant species today, will no longer be able to perform photosynthesis. Think about that. The vast forests of the Amazon, the sprawling grasslands of the Serengeti, the towering sequoias of California, all destined to starve. Some hardier C4 plants might hold on for a few 100 million years more, but their fate is also sealed. As plant life vanishes, so does the planet's main source of oxygen. The atmosphere we know today, with its life-giving 21. Section 3. Earth's expiration date, the 1 billion year mark. Now we arrive at the official expiration date for life as we know it. A joint study by Toho University and NASA, running over 400,000 different simulations, has pinpointed this moment with astonishing clarity. In approximately 1 billion years, Earth's oxygen-rich atmosphere is projected to fail. The relentless solar heat will trigger what scientists call a moist greenhouse effect. Surface temperatures will rise, causing the oceans to evaporate at an accelerated rate. This water vapor is a powerful greenhouse gas, trapping even more heat and creating a vicious feedback loop. The upper atmosphere will become saturated with water, where intense solar radiation will break the molecules apart, letting precious hydrogen escape into space. With photosynthesis all but gone, there's nothing to replenish the oxygen. Instead, the atmosphere will become dominated by methane and nitrogen, just like it was before the Great Oxidation Event over 2 billion years ago. oxygen levels are predicted to plummet to a tiny fraction of what they are today. The ozone layer, our shield against deadly UV radiation, will disappear. The result is a planet that can no longer support complex oxygen-breathing life. Humans, animals, insects, fish, everything that walks, crawls, swims, or flies will be gone, suffocated on a planetary scale. It will be a world fit only for anaerobic microbes, a return to the planet's most primitive biological state. Scientists estimate this final rapid deoxygenation could happen in as little as 10,000 years once the tipping point is reached. So while some models suggest aspects of life could hang on longer, you can pretty much mark your calendar. The end for our kind of world is set for about 1 billion years from now. Section 4. The Final Act. A World of Fire. But the planet itself will endure, at least for a while longer. After the last breath of complex life is gone, the sun's assault continues. The slow march of temperature rise becomes a sprint. By around 1.6 billion years from now, surface temperatures will hit about 65 degrees Celsius. And by 2.8 billion years, even the poles will reach a blistering 149 degrees Celsius. At these temperatures, any remaining pockets of life, even the hardiest microbes, will be sterilized. Earth becomes a completely barren rock. The magnetic field generated by our planet's core may also shut down, stripping away our last defense against the solar wind. Then, around 7.5 billion years from now, the sun enters its final, spectacular death throes. Having exhausted the hydrogen in its core, it will begin to fuse helium. This change will cause it to swell dramatically, transforming into a red giant. Its size will bloat, growing over 200 times larger than it is today. The expanding star will engulf the inner planets. Mercury and Venus are doomed, certain to be swallowed by the fiery plasma. What about Earth? For a long time, scientists debated if our orbit might expand just enough to escape. But recent models suggest that's unlikely. The intense gravitational pull from the bloated sun will likely drag Earth inward. Our planet will be vaporized, its oceans will have long since boiled away, its atmosphere stripped, and its crust melted. Finally, the very rock beneath our feet will be consumed by the star that once nurtured it, its atoms scattered into the sun's outer layers. The story of our world is written in the stars, with a definitive beginning, a vibrant middle, and an inevitable end. It's a humbling and pretty awe-inspiring perspective. If you find these cosmic journeys as fascinating as we do, subscribe for more explorations into the biggest questions of our universe. And let us know in the comments, what does knowing this timeline make you feel? In about 8 billion years, the sun will have shed its outer layers, leaving behind a beautiful planetary nebula and a dense, cooling core called a white dwarf. Our solar system will be dark and silent. Knowing this expiration date isn't a reason for despair. If anything, it's a profound reminder of our place in the cosmos. Life on Earth is a fleeting, precious moment in the grand timeline of the universe. We exist in a brief, habitable window that will inevitably close. It highlights the staggering improbability of our existence and gives our time here a deeper meaning. Humanity's story may be a brief chapter in Earth's multi-billion-year saga, but it is the chapter that is aware of the beginning and now the end. What we do with that knowledge, and the time we have, is the one part of the story we still get to write.